for this, what apparatus we need? We need the source where sound waves are producing. Okay, and you see those source may be a loudspeaker because from there sound waves are coming. So if we are approaching towards the source, so we will see so that frequency of that sound waves will increase. So when we are moving away from that source, so you see frequency will decrease. So this is due to the Doppler effect. So what frequency value you are getting, so we will find that in this experiment. So if you have a source, so you need a detector. From there you will detect that sound. Okay, or you can say the one point is that observer that can say that now its frequency is increasing or decreasing, but we are not able to give the value. So what frequency it is having. Okay, so detector we need for that, to what frequency it can measure using that detector. Okay, so these are the apparatus required. And what is Doppler effect? Because according to Doppler effect, when this relative motion between source and observer is there, so there will be change in frequency of those waves will be there. Okay, so this is the Doppler effect. So why this is written here that electromagnetic waves? So it can be electromagnetic waves or the sound waves. Okay, so when sound waves are coming or electromagnetic waves are coming, so there is a relative motion between the source and observer. So then the change in frequency will be there. So this is a Doppler effect. So whether this source and observer, they are moving close to each other or they are moving towards each other, so that frequency will increase. So they are moving away from each other, so in that case frequency will decrease. So this is the Doppler effect. And you see there is observer and it is a source here. So when the source is coming close to the observer, so frequency will increase. So that means upward shift in the frequency will be there. And when this source will move away from the observer, so downward shift in that frequency will occur. Okay, so this is the Doppler effect. So who observed this Doppler effect in the first? It is observed by Christian Doppler in 1842. So this is the effect. Firstly, it was observed by the for the sound waves. So even they have used these Doppler effect for the moving objects like galaxies, because in that case waves are coming. So that waves are, if the we are getting the wavelength which is, or you can say the frequency which is reaching at some other planets. So if that frequency is changing, so we can say that they are moving away from each other or they are moving close to each other. So in this way, so if you are getting the redshift, so that's why they are saying that they are going away. Okay, so that means due to the redshift they have observed. So this is the due to the Doppler effect they have observed these things. And because you say you can see in this figure here, so we have a source and we have observer. So if this source is moving away from that observer, so redshift will be there. Because when this observer is moving away, the source is moving away from the observer, so we see that the frequency will decrease. So if frequency is decreasing means wavelength is increasing. So when wavelength is increasing, so what color they are having? Because we know that according to Vibgyor pattern, so red color has a higher wavelength. So when it is moving to the higher wavelength, so you see red shift will be there. Okay, so when we are talking about the light waves, so we are talking the shift in terms of colors. Okay, so red shift or blue shift. Okay, and when the source is moving close to the observer, so that frequency is increasing. So when frequency is increasing, means wavelength is decreasing. So when wavelength is decreasing, so we will talk about in the blue shift, that the wavelength, if any wavelength is decreasing, so that means it is shifting in the blue shift it takes. Okay, it's not in the upward shift and the downward shift. So we will talk about if any wavelength is increasing, so we say red shift is there, and if a wavelength is decreasing, so blue shift is there. So when we talk about in the light waves, and when we talk about the sound waves, we only say upward shift in the frequency or downward shift in the frequency is there. So this is a Doppler effect. And if this source, you see expression number 1 here, we have f naught. F naught is the actual frequency of those sound waves. Okay, and v and v naught and vs. Okay, because those sound waves have some velocity. You know, as we have done the ultrasonic interferometer also, so their ultrasounds are producing. So those sound waves have some velocity. Those sound waves have some frequency. So when we this observer is moving, or source is moving, where these waves are coming, so they are also moving. Source has some velocity, observer has some velocity, sound waves has some velocity. So if we take the relative velocities of those, okay, so if we are taking the relative velocities and finding the, then ultimate the what observer will get that frequency for the sound waves. This formula is given by 1 when equation number 1 when they are moving towards the source, okay, and when this observer is moving away from the source, so this formula will be given by equation number 2. Okay, so you can see from equation number 1 that in the numerator you will have v plus v naught. That means something is increasing. Okay, and if you have this expression number 2, v minus v naught is there, so that is decreasing from v minus v naught. So that means this frequency is decreasing when moving away from the source, and it is increasing when moving towards the source. So these are the formula that we will use to find out the frequency. Okay, so in this experiment, what you have to do, you have to only give the values for the velocities and the actual frequency of that wave. So the detector just only tell you have to just only select the direction that they are moving towards each other, or they are moving away from each other. So the frequency is detected by detector only. Okay, so you just verify that they are coming close to each other, so frequency should increase. So when they are moving away from each other, so frequency should decrease. So what value you are getting, so you can get from this formula also, and directly you can find from the. Okay, so two readings that you have to take. You see velocity of source that you will give, velocity of detector you will give, source frequency you will give. Okay, so these value you will give from the slider or from the simulation link, and only the thing you will observe when they are moving close, see the value, and when they are moving away, see the frequency value. So this is a Doppler effect. Okay, so when we do this in the lab, in the manual lab, so we are just observing the frequency, so what value you are getting from that detector. Okay, so accordingly we will see, okay, frequency is increasing or frequency is decreasing. So in this way we have the detector and it is giving the value, okay, that this frequency is increasing when they're moving close to each other, or they're decreasing when moving away from each other. Okay, so these two values that you have to take in this experiment. So you see you have a source. From this source sound waves are coming, and you have detector. Okay, so you see detector is showing some frequency, because according to here this frequency is given, okay, in this variable here. So if 100 frequency you have given and they are not moving now, so if they are not moving, so same frequency it will give. Okay, you see these are the waves, those are coming from the source, and these are the waves, those are detected by the receiver, or you can say detected by the detector. Okay, so you see same sound waves you can listen, but as you will move, or you see there is a relative motion between these two. So if they are closing, if they are coming towards, if this observer is coming towards or moving towards the source, the frequency will increase. So exact frequency it's 100, but now you see when they will close to each other, moving approaching each other, so that frequency will increase, and when they are moving away from each other, frequency will decrease. So we will see what effect they will have. So you can select the medium also, and in the water medium and the glass medium, so different medium that you can select when you want to observe this Doppler effect. Okay, so you can also select the source direction. That means this source is moving in the right direction, okay, when you give its velocity, and this receiver can also move in the left right direction. So that it's up to you that if suppose I have taken right and the right. Okay, so what velocity I have given? If suppose I have given 200, if suppose I have given, suppose I have given 200 source velocity to it. So now you see as I have given, so this source is moving now. So now frequency you can see from the detector. Yeah, you see. So you see, firstly it's 100. So when it is coming in that region of the sound waves, so this frequency is because that source is moving away from that detector. Okay. I can give the same also. $150. Yes, are you seeing this frequency from the detector? You see now they are close to each other now. You can see frequencies increase. So when they are going away, frequency is decreasing. Yes, can you see this? Students, can you see this?
Yes, ma'am.
Okay, I have given source velocity, I have given detector velocity. Okay, frequency I have given 100 to that source. Okay, exact value it is 100. So when they are moving close to each other, you see frequency increased. So when they are moving away, you see 35.5 is observed. Yeah. So same frequency you can see it's giving in the result also, and you can also calculate from that formulas. So these values should same. Student, it's clear how you will perform this. You have to only give the values to source, detector, and this frequency. Okay, so these value you will give, and you will see what values they are coming. Two values you will have to calculate. So if you change the velocity, if you say I have increased this velocity now, so according now different how so high frequency that you will get as I have given so much, and they are moving close. Yeah, you see. So these type of waves are received by receiver. You see, coming from source, it is like sinusoidal waves, and what the detector is observing like this. So when they are moving, so this is according to Doppler effect. You see in this table, it is given source velocity is given 175, and detector velocity it is given 200, and source frequency that is adjusted at value 160. Okay, so these are the value you have to adjust from the that sliders. Okay, so you are adjusting those values, and how you will find the frequency. You see, one frequency you are getting from the detector. Okay, so when they are moving towards each other, so it's showing some frequency, and when they are moving away from source, so they are giving some frequency. So this is how you will perform this experiment, and these value you will get also from these formulas. Okay, the frequency you will have given. Okay, V naught you have given, Vs you have given. So now the velocity of sound waves. So these velocity of sound waves you will put the value 343 meter per second. Okay, so this is the value you will put for the velocity of sounds. So using those values you can find out the frequency. Okay, so this is the frequency when we have adjusted these values, and as I have adjusted 150 and 200, so accordingly and I have given the source frequency 100. So when I have changed these frequencies, so my detected frequencies were also different. Okay, so those value you can also get from the this formula also, and we have observed these frequencies in the experiment also. So that means you can see theoretical values and experimental values are in good agreement. Okay, so these are we are detecting experimentally, and these you are finding theoretically. Okay, by finding the relative motion between those observers and finding the frequency. So this is how you will perform this experiment, and it's very easy experiment. You have to give the velocity terms also, these frequency you will have to adjust, and find the detector frequency.